Hello everyone, welcome back to Project Pro YouTube channel. This is me Simran Anand, and in this video I'm going to be explaining you about a really prominent topic, which is Docker. So I'm going to be explaining you how Docker can be leveraged for data science and data engineering projects. What is the essence of Docker in today's industry? Docker has variety of applications not only related to data science, but also it has various applications in DevOps and software engineering, and especially it's booming in the field of MLOps. So I'm going to explain you how some of the Docker keywords and the key terms you should be familiar with, and how Docker can, some of the project ideas you can build in data science domain in order to get started with Docker and understand how machine learning projects can be deployed very easily with Docker, and some of the commands of Docker. So let's get started. So you must have heard about the virtual machine concept, wherein you must have heard about the different virtual machines which are available. And when you want to run any application in your system, there were instances where you had to install virtual machines like Oracle VMware or Oracle Virtual Machine or Oracle VirtualBox. But then the concept of containers came in, and then we have Docker as well. So what is exactly Docker, and how do you think Docker plays a major role and can be leveraged for data science as well? So basically, in 2021, Docker witnessed 1.5x growth according to the statistics, because deploying the same projects on different machines with different configurations is becoming increasingly difficult. So say that you are running a project, and the same project of Python, and it has a lot of many dependencies are there with different versions. So when you want to run the replicate the exactly the same project in someone else's, your team member's system, the other team member might be encountering various errors like dependency issues and so on, and it takes a lot of time in order to debug those dependency issues and resolve such kinds of errors. So Docker makes it very easy, because the concept of platform independence can be achieved easily with Docker. So that was one major advantage why Docker came in. And especially when you talk and compare Docker and containerized containers, especially with virtual machines, they have several advantages over virtual machines, which I'm going to be discussing later. But basically, so you must have understood by now that Docker has solved the problem of basically memory usage. It optimizes the memory, the space, time to load, and also in order to deploy applications. So you can deploy machine learning projects very easily with Docker. Even after fulfilling all the requirements of your project, you waste a lot of time resolving such errors, as I've told. So Docker is the solution over here. So basically, Docker provides the ability to package and run an application in a loosely isolated environment called a container. So you must, when you're talking about Docker, there are terms like container, images, host engine, you must be acquainted with. So when I say Docker isolates, Docker packages all the dependencies, the software code, the tools of your application to run your program, and in an isolated environment called a container. What does this exactly mean? So the isolation allows you to run many containers simultaneously on a given host. It is so Docker, in simple words, is a software that contains. Since Docker can be termed as a containerization tool. On the other hand, you must have also come across terms like Kubernetes. So Kubernetes is an orchestration tool. On the other hand, Docker is a containerization tool. So let me explain you. So it can be thought of as a software that contains all the tools required to create, handle, and run containers. So it packages all the software codes, the dependencies, the tools, libraries, and everything which is actually required to run your program or to run your application, such that your application can run the same way in exactly the same environment on someone else's platform or someone else's operating system. That is one advantage of Docker software. So coming to what is basically what makes containers better than virtual machines. So virtual machine definitely has an advantage that you can run this application on someone else's system, because the dependencies are also present in the your team member's system. But why exactly containers are thought to be better than virtual machines is because of the fact that virtual machines, they take up space, they take up a lot of memory and time as well. So if you take a virtual machine, it requires a separate operating system altogether. But on the other hand, containers, they just require one single operating system to run. That is a major advantage of containers and why they are thought to be better than virtual machines. So the operating system, utilizes RAM, CPU, storage, which cannot easily be leveraged for powering other applications. So one has to purchase purchase a license for every operating system. But on the other hand, when you make use of containers, although they are similar to virtual machines, you don't have to buy licenses for separate operating systems. Containers can work on a single operating system. And that is why they are thought to be better than virtual machines. I hope I have made this concept of why containers are preferable over virtual machines, not only in terms of the memory usage, but also because they can work, multiple containers can be run and work together only with one single OS only. So that is a major advantage. Next comes in, how can Docker be used in data science? This is a very interesting topic, I would say, and an interesting question, because data science is, first of all, a booming industry. And on top of that, Docker is very much essential these days and will be in demand throughout the industry, not only in DevOps, data engineering, but also in software engineering, because when we're working with microservices or with a lot of deployments, so Docker is one such containerization tool, like I've said, which helps you to package all your software requirements, the codes available, into a container so that they can be easily portable, scalable, and deployable. That is a major functionality of Docker. So when it says how can it be helpful for data engineers and data scientists, there are a lot of ways in which Docker can help them. So Docker files allow data engineers to smoothly deploy big data projects by using containers for running them on the host machine. So by making use of this containers, this is why they're they're packaging all the software code and making the job of a data engineer as well as a data scientist really easy for deploying their machine learning projects, so that more time the data scientists can spend on actually creating than deploying and configuring and managing the code on the cloud. Also, by Docker, you will be able to understand how exactly is the deployment happening to the cloud. So thus Docker is becoming a really prominent skill in order to learn, and also is also a hot topic today. So basically, it allows us to smoothly scale and deploy machine learning and deep learning applications. And like I've said, you just have to create a Docker image of the project, and the whole team can use and run with the Docker server. So you just need to install nothing but except the Docker. So if you have the Docker desktop, which is a GUI tool, and Docker desktop is basically you can say you have to install. It makes the task very easy in order to manage and ship your containers. So you must you come across terms like say GitHub, like you're talking about the version control. You have Git and GitHub. Git is for the command line interface and for version tracking, for your project tracking, collaboration, and for version control. On the other hand, GitHub is the GUI or the graphical user interface. Similarly, we have Docker and we have Docker Hub. So Docker Hub is the GUI platform. It's basically a GUI platform, software as a service tool, which is for basically for building your repositories, and it can be thought of as a registry for all your repositories to be saved. So if you are building a Docker image, you can push and pull all the images onto and from Docker Hub. That is a Docker Hub method, the Docker Hub term. So you just have, so whenever you're just building any data science application or a project with your team, you just have to build or create a Docker image of the project. You can share it with the team. You can push it to the registry, which is Docker Hub. So that is the main advantage. It makes basically the job and the task of packaging really easy for the data scientists. So they can easily package data pipelines, run them on any part of the world using Docker images, and the Docker images are remotely accessible from any part of the world. Similar to how you can, access projects. You can share and collaborate on different projects when you upload them to GitHub. Similarly, you can push your repositories to Docker Hub. You definitely have the access of making it the private or the public repository, but in this way, you can collaborate and you can share Docker images so that exactly the same Docker image can be reproduced and replicated by your team member on their system, and they don't have to go through all the dependency issues and again resolve all those conflicts, because it has a Docker file. When you run the Docker image, the Docker file is there, which can be thought of as all the requirements of the software are included in the Docker file. So whenever the team member is replicating your code, all the such issues of Docker dependency issues and such will get resolved. So using Docker and Kubernetes. Kubernetes is a container orchestration tool which makes your management of containers really easy. It basically automates the entire process workflow, but Docker is a containerization or a packaging tool. So one can quickly build scalable projects and manage them effectively. So coming to how to Docker, install Docker in your system, you can definitely go through the Docker, the official documentation of Docker, and you can just have a look at the Docker docs desktop. So if I just click on this link over here, It will help me or anyone in order to understand what is Docker Desktop, how it can be installed onto different operating systems. So you can install Docker on Windows or Linux and so on. So if you're installing Docker on Windows, exactly the steps in order to which are required in order to install Docker on Windows are enlisted over here. So you can have a look over here. These are the official Docker documentation. You can go through them and have a look at how to install Docker into your system. So Docker Desktop, as I've told, is a software as a service. Provides a straightforward GUI, which is graphical user interface, and lets you manage your containers, applications, images directly from your machine. So it can be used either on its own as a complementary tool to the CLI or command line interface. Coming to what a sample Docker file. Now we have talked a lot about Docker, what Docker. I might have repeatedly told you about how exactly Docker is becoming really important these days, especially now that you've understood how you can leverage Docker for all your projects. You must have now I've also told you that the requirements of TXT, whenever you build any Python program, you have the requirements of TXT files. So similarly, you need some kind of a file which is enlisting all the instructions you can follow whenever you are trying to replicate or reproduce a data science project or say any project. So for that case, we have a Docker file. This is a sample Docker file which I have mentioned here. So it has this is the base OS or the base operating system. So it's written Python 3.8. The 3.8 is a version of Python. So next line says work directory. You need to have a working directory where you can copy and add all your Docker, copy and add all your Python folders and files. And save them. So as soon as you go to your VS Code on any ID and then save them, try to make a Docker file, it identifies. So you should have Docker. If you have the Docker desktop and the Docker extension in VS Code, say, VS Code will be able to automatically recognize that it's a Docker file and help you with all configuring it properly. So you need to add a work directory. Firstly, this is the work directory where you are going to install all your requirements and add them. So add ./app, and also you must be aware before delving into Docker and to perfect Docker, you should be aware of Linux commands, because that will help you in order to understand Docker. So once you understand Linux, it will be very helpful for easy for you to understand Docker, to understand what is Docker Compose, Docker Swarm, and other such technologies. And then later you could dive into Kubernetes, which is after understanding the containerization tool like Docker, you can actually orchestrate your program using Kubernetes as well to actually build a production ready application. So you should be aware of Linux. So in Linux we have a command which says it's a current directory. So that is exactly, so add ./app. So into the current directory, the folder, you're adding all the Python projects which you want to add and copy into. So run pip install our requirements.txt will install all the necessary requirements of your which contains the requirements file, contains all the Python dependencies and the frameworks, which the libraries basically, along with their versions, which have to be installed into your environment. Once you do that, expose 5000. This is the basically the port you can expose your application to. So it's 5000 over here. Then end name open to all. The environment name can be set by you. So this is a sample environment name variable which is open to all. Command. So whenever you're trying to run a Python application or Python program, you simply say Python app.py. So whenever you want to run a Docker application or Docker file, this is a command which is Python app.py enclosed in square brackets. This is the command. So that this entire these steps, basically the instructions, which is something like an algorithm, we can say, enlisted into the file which is called as a Docker file. It serves as a template for you in order to build Docker image. So once you have and execute this Docker file, the Docker image will be built, and then from the image you actually have the container. So this is a sample. Suppose if you're running, it need not be even a Python application. If you're actually have a Streamlit file, a Streamlit is again a Python package which is used for building web applications in the front end. So when you have Streamlit file, you write the command like streamlit run streamlit.py or streamlit run app.py. So for that, in this sample image, if you see here, there's a command app.py, and in the entry point you have to mention streamlit and run. So in this there is no entry point because this is a sample and it's very simple file in a Docker file. But if you're running a Streamlit application, then the entry point would be streamlit run, because this is the command streamlit run app.py. And app.py will be there at the command, and the rest of the steps will be exactly the same. There's just copy I have added over here, Along with add, you can also copy any files and folders into the working directory of yours, which is /r. So now that you've understood what is Dockerfile, the purpose of building a Dockerfile, from the Dockerfile, what you get is a Docker image, and then you can build the image and push it. Once you see that all the dependencies and your application is actually packaged properly or containerized, you can actually push the container from the image, Docker image. You can push the container to the registry, which is the registry is nothing but the Docker hub. So you can push your image there and then also share your Docker images to people or to your team members. So this is the architecture of Docker. The three most important commands I would say for Docker is Docker build, which will help you to build a Docker container, a Docker image. Docker pull, which will actually pull the image. Now, what is pull exactly? So if if you're familiar with the GitHub commands like git push and git pull, it's exactly the same. If push is something when you're uploading or you're pushing your files and your Docker image to the registry, which is Docker Hub. Similar to GitHub, you're pushing a project to GitHub. Similarly, when I say pull, you're actually pulling the Docker image from the registry, which is Docker Hub, into your local system and working on that, so that you get the base Docker file from there, the Docker base image. So Docker run similarly is used for running the image of yours. So there are different commands associated with it, which I'll be delving into in this slide. So this is the basic, simply the architecture of Docker. Then you have the Docker host, Docker daemon. Docker daemon serves as the backend process. So it responds to all your Docker API calls and so on, and makes and all the requests you make. So it's in the backend process. And then you have the Docker images, which serve as the blueprint for you or a template for you to actually build your Docker application. You to build your application, it's a blueprint. Then you have, from the image, we get the Docker container, which you can build. We can actually run and build the Docker container, which these are like lightweight in nature. They're standalone environments, so that everything you are packaging, your software, the tools, the code, as well as the libraries, is in a very loosely and isolated environment called a container. So container is a loose and a isolated kind of environment. And then you have a registry where you can push your Docker images you have built successfully. You can actually push them to Docker Hub, as I told, and you can similarly pull them as well from the Docker Hub. Now that you have understood what is registry, what is Docker image, Docker commands, I'll just quickly skim through some of the general commands you must be acquainted with in order to get familiar with Docker and building Docker projects. So to start the Docker daemon, this is the command, which is Docker -d. Docker -d and then the image name. That would be the to start the Docker daemon, Docker -d. Then get help with Docker is Docker -help. This is to get help with all kinds of Docker commands. Similarly, for displaying system-wide information, Docker info is the command. To push a new tag, so this is my username, Simran1102. I will just show you the how the interface over here. This is the Docker Hub. So I've just simply typed hub.docker.com on Google, and here you will get the Docker Hub. So in the Docker Hub, I have just recently pushed a getting started image, a Docker image. So over here, you can add your description. This is a Docker command to push a new tag to this repository. So you have repositories here. Similar to GitHub, we have repositories where actually we are storing our projects and we are storing our images. So in repository, we are actually storing images, and we have associated tag for each image. So my tag name over here is latest. So if I just go to latest over here, the type is image. This is a Docker image of mine, and which I have pushed it to Docker Hub. The layer details, if I go to image layers of here, all the commands and the layers, the commands over here are the Docker file instructions, basically. So in my Docker file, whichever instructions line by line I had saved, all these are getting executed as layers when I try to run the Docker file. These are the layers, basically, like expose, env, cmd, entry point. These are the commands which I included in the Docker file. So this is the interface of Docker Hub you can go through. You can also go to repositories and explore. If you go to explore, all the built-in Docker images will be shown to you, displayed to you. So you can just go to Alpine Engine. So for example, just go to Nginx, and over here, this is the official build of Nginx. So you can, in order to, if you want to pull this, basically similar to how you're cloning a GitHub repository into your local system, if you want to pull this Nginx Docker image to your local system, you can just make use of this command, Docker pull Nginx. So that was a small introduction about Docker Hub as well as the GUI tool. So this is my username, Simran1102 slash getting started. Getting started is my Docker image name. Like I've just shown you right now, when I go to repository section over here, whichever, these are the three repositories I've built. You can also make it public as well as a private repository. So this is my public repository with the name, this is my username, and getting started is a Docker image. So the Docker image has to be passed in over here, followed by a colon and a tag name. That is how you are actually pushing a new tag to a Docker Hub repository. Now that you've understood these general commands, let's get into some few basic Docker commands for images. So to build an image from a Docker Hub, this is the command: Docker build -t image name. And to build an image from a Dockerfile without the cache, this is the command. To list local images, Docker images is the command. So see, these all commands will be, you will be getting familiar with them when you actually build a project and get hands-on practice. So definitely all these commands are enlisted also in the Docker official documentation. Whenever you want to refer them, you can go to the Docker official documentation to actually, or you can also go to this command, which I was saying, Docker --help, which will actually help you with all the Docker subcommands and commands in Docker. So these are few Docker basic commands for containers as well. So in order to create and run a container from an image with a custom name, so Docker run --name, container name, and then the image name. Now you have to understand that container is different from an image. Like I've already told you, container is like an isolated loose environment, whereas an image is like a blueprint or a template for building a application. So in order to create and run a Docker container, the first command over here is the command to run a container with and publish a container's ports. This is how you specify the host port followed by a colon and then the container port. To run a container in the background, Docker run -d and then the image name is to run a container in the background. So in order to list all the running containers in your system, say that you have multiple containers and you want to just have a look, you want to know that what are actually the running containers in the process, Docker ps will list you all the currently running containers. So that was all about it. Some of the commands, general few basic commands you should be acquainted with. Then basic Docker commands for Docker Hub. In order to log into your Docker Hub, so this is what this is the Docker Hub I was showing you, the GUI platform. So if you want to log into Docker, Docker login -u and then your username, then publish an image to Docker Hub, Docker push username / image name. So in my case, it's Docker push my username Simran1102, then / image name. Image name is getting started. So if I want to push from my local machine to the cloud, and Docker Hub is in the cloud, so if you want to push it there, you can make use of this command. And similarly, to search Hub for an image, you can make use of Docker search followed by the image name. Pull an image from Docker Hub, as I've shown you, Docker pull image name. So that was all about it. Now to coming to the key terms of Docker and to make you understand as to what all key terms are, you should be familiar with: Docker image, container, Docker file, Docker host, and Docker compose. So coming to this Project Pro article on leveraging Docker for data science, you can have a look as to what are the basics of Docker you should be familiar with. And now that I've given you just about what is Docker, the basic commands, the key terminologies you should be aware of, and how Docker is playing a really important role in the DevOps and the MLOps software industry. So how exactly is Docker helping data scientists is one big question, and one something I would like to elaborate on. So see, applications that run in containers are indifferent to the features of the individual system. So there are different configurations of every system. So in order to make an application with an environment to exactly run the same way on different applications or on different platforms, this is where Docker comes into the picture, because the concept of platform independence is achieved. So Dockers allow users to connect to hosted containers across the world. So you can remotely access all your applications and thus making it portable. So portable scalability is something which Docker helps the data scientist to achieve. And also it makes faster deployment of project applications. Learning Docker for machine learning projects will prove helpful because more and more companies are likely to use Docker for deployment in the future. So definitely it's a very, I would say a recommended skill if you are very much interested into the deployment part of machine learning. So Docker for data engineers as well. Docker files, like I've shown you, contain or enlist the instructions for actually building a Docker application. So Docker files allow data engineers to smoothly deploy big data projects by using containers for running them on the host machine. So just like Docker allows reproducibility, the main term over here is reproducible. So when you want to actually create or build reproducible data science projects, Docker is the key. And it is easy to package data pipelines and run them from any part of the world. So that is how you can make use of Docker, Kubernetes to actually build scalable projects. Some of the Docker projects ideas you can look into for data science especially are running a Linux application with Docker. There is on this Project Pro article, you can go to the GitHub repository, which is a sample web app for practicing Docker. In this way, this is a beginner level project for you to get acquainted with Docker. Another interesting is running a Windows application with Docker, similar to like how this for the Linux, this is for the Windows. Then getting started with Docker for data science. Predicting customer license status is something which is a machine learning and a data science project, data science domain. Similarly, Dockerizing this particular application, which is to deploy a classification model and MLOps using Docker. So how that could be done is also enlisted in this article. Abstractive text summarization definitely is very interesting NLP application you can look into. And resume parsing system, definitely, like in my previous video, I was talking about OCR, especially when you are actually extracting the textual characters from a PDF document, say your resume. The same thing can be actually Dockerized. You can containerize all the applications and make it you can deploy it on Docker Hub, and you can push your Docker image which you have built to Docker Hub. In this way, it makes reproducibility of data science projects really efficient. Automating the deployment of the application is something you can look into in order to understand how Docker is working, the key terms of Docker, and how to actually build multi-container and how to manage scalably, how to manage the multi-container Docker applications. For that, you can also look into Docker Compose for multi-container applications. So that was all about it. I hope I have given you an inclination and ignited the interest for how Docker can be used for leveraging data science projects. So that was all about it. So do check out Project Pro. It has end-to-end projects which are it contains projects, recipes, tutorials for you, and all the projects are created by top industry experts working the top global tech companies. Do buy the Project Pro subscription plan to avail access to more than 250 plus solved end-to-end projects. And do stay tuned on the Project Pro channel. Like, share, and subscribe.